Creep is expressed as the stress required to produce a prescribed strain at a prescribed temperature over a prescribed time period. A reference point for secondary creep is 1% elongation at 100,000 hours, approximately 11.4 years. Data are usually taken on specimens subjected to uniform tensile stress and uniform bending moments. The data generated are difficult to apply quantitatively in real-world applications because they are based on pure loads with no variation in load or temperature. The data are useful for eliminating some alloys from consideration and for comparing the relative merits of several alloys in a given application. See Figure 1, Stress versus Temperature, for 0.1% creep strain for a comparison of creep profiles at varying temperatures for the most common aluminum, magnesium, and zinc die casting alloys. Relaxation is a variant expression of creep. The term applies to conditions such as interference fits and swaged joints where stress, and consequently the retained load, diminishes while there is essentially no change in dimension. Where an analysis of operating conditions indicates that creep can occur, the following design procedures will minimize the effects and often achieve an acceptable design. Designed to reduce or eliminate bending, tension and shear, and keep the material in compression. For example, through bolting with steel bolts, nuts and washers is preferable to bolts in tapped holes because the threaded loads are in the steel rather than the die casting. Reduce stress levels in critical areas. For example, washers under nuts and bolt heads and increased depth and diameter of threads increase the area of load carrying metal. Utilize additional methods of retention at joints, such as bolting or staking, where members are retained by press fits.